This is my name. But
and I saw something that I think would actually be really good for him.
So is this just, how come this is a very, this lecture's available to other people as well?
What do you mean to other people?
Well, I presume it's also for students.
Anyone in the college, I think. And I don't know if it's anyone else who's affiliated or... I'm not really sure. So they have these events all the time. I've never actually been to one where they have like different talks. Brian Cox is supposed to. They're always very good. Like they do all these things, they do this other thing called Imperial Lakes as well, and you can bring anyone you want to bring your friends. So I was thinking Dad might have to come to one of those. It's like the evening stuff.
Yeah, we can't do the test drive tomorrow. The car has got a flat tyre. It has to be Friday or Monday.
Also, I think that's like
How's it going, Teresa? That works.
it's like it's at the dealership.
They have to order one in.
That's the lamest thing. It's lame.
I've already got somebody who's doing me a hard sell. I'll send everything done tomorrow. We should be able to get you a pint of 18th of March. I've got some, when he comes back, if he's pretty good.
Hey, how's it going?
Guy says I can
I think we met at Odo one time. Yeah, good to see you again. Yeah, how you doing, Teresa? Cool.
So we put a load of our, I put an order in for some bits to try because we're gonna spend 10 million grand on the studio.
Oh, right.
Well, it's the only chance we can do it.
Did you ask Shona yet about that? Did you ask Shona about that?
But we need one thing we need is a new Mac.
Oh, yeah. Did you ask Rob?
hello, 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 hello. Okay. Good evening. On behalf of the Dyson School of Design Engineering and Imperial College, I want to welcome all of you, both in person and also remotely, to this lecture. My name is Peter Chung. I was, until last summer, the head of Dyson School of Design Engineering, and today I'm chairing this event. I guess I was asked by the current head to do this job because in no small measure, I was responsible for Andrew coming to join us at Imperial College. For inaugural lecture at Imperial College, usually the victim would have spent years with us for me to collect a lot of interesting stories. Unfortunately, it's not going to happen tonight. Andrew only joined us just over a year ago, and he behaved immaculately. I was tempted to ask Ruth to tell me the dirt, but I thought I better not risk their relationship. Well, instead of doing that tonight, I'm just going to tell you about Andrew's journey to come from United States to the UK, and then eventually join us at Imperial. It started with Andrew going to MIT to study his undergraduate degree. I have no idea what he was like when he was a child, but I was told that I'm going to meet his parents tonight, so I'm going to find out. He went to MIT not contented with doing one degree. He actually completed 2 degrees at MIT, a bachelor degree in music and a master of engineering degree in electrical engineering. In 2009, he also finished his PhD at University of Pennsylvania. His topic is music composition. Then after 2 years as postdoc in Dressel, 2011, he came to the UK with Ruth. I understand, and Ruth joined Imperial College at the time. And Andrew joined Professor Mark Sandler here, who will give the vote of thanks. He joined Mark at Queen Mary, University of London, and became a lecturer, and spending just over 10 years, rising rapidly from lecturer to professor, and then he got poached by us. 2 years ago, in 2022, Andrew contacted me in the summer, inquiring if Dyson School has any opportunity for him. I read his CV carefully and realized that he has a perfect fit to what we do at design engineering. If I have to use 4 words to describe us, then the 4 words would be scientific, creative, socially responsible, and entrepreneurial. That's actually 5 words. Andrew clearly fit at least 3 out of those 4 things. He is technically a very competent engineer. I know that because he helped me in one of my technical modules last year. He is clearly creative, otherwise UPenn wouldn't give him a degree in music composition. That has to be creative. And finally, he's very entrepreneurial. In the time that he was at Queen Mary, he founded 2 startup companies. So there he is. Just over 1 year ago, we managed to get him to come. I feel a bit guilty because we stole him from Queen Mary. And I decided that I have to invite Mark over here to compensate with giving him a good lunch. And in the last just over a year, Andrew has integrated very well in our department, has already currently teaching a course to 100 students in our 2nd year. So without delay, may I invite Professor Andrew McPherson to come up here and deliver his inaugural lecture on making technology to make music. Andrew.
Thank you so much, Peter. Thank you for the lovely introduction. And thank you all for joining me here tonight in the room and also online. I'm just so pleased to be able to share this occasion with you. I just want to start by basically saying that one of the best parts of my career has been to work with the fabulously talented and creative group of people who make up the Augmented Instruments Lab. Even beyond the joint papers and projects that we do together, I really owe a lot of the ideas that I've had over my career to working with you all. So thank you so much. It's really been an honor and a pleasure. Here are the alums from the lab, and I wish I could spend this time just telling you about all the different projects that they've done. But if you'd like to read more, you can go to the lab website at instrumentslab.org, where you can find more about our past and current projects. Now, as you can see, our research centers around designing digital musical instruments. And you might ask, well, why would you do such a thing? So let me tell you a story. Now, at first, this story is not going to seem like the stuff of a professorship at Imperial College London, but bear with me, and through the twists and turns, I hope that it will become clear. So, the year is 2009. The location is Philadelphia, Pennsylvania, and in the Fisher-Bennett Hall at the University of Pennsylvania, something shocking has happened to this poor piano. Now, this is also a very boring crime mystery, right? Because we already know the perpetrator. I mean, I literally set the thing up outside. Thank you, Lewis, by the way, for the help in setting up the MRP earlier. What we don't know about this is the motive. Fortunately, the perpetrator left some clues at the scene. Here's a flyer that I made right around this time. It's a concert poster, and as you can see, I'm calling this contraption the magnetic resonator piano. I want to tell you about this more or less as I would have at the time. The motivation is this. How do you play this on the acoustic piano? It's a note that begins softer, gets louder, and gets softer again. Now, musicians in the room will know, of course, this is completely impossible. And the reason is that the piano is a percussion instrument. When you press the keys, a series of wooden levers move, and it causes the hammer to fly up and strike the strings. The strings ring, they decay over time, and the upshot is you have very little ability to manipulate the sound of each note after you have struck it. Okay, what are we going to do about that? This is the magnetic resonator piano. This photo is from a couple years later. What on earth is going on inside this piano? This is an example of something that is called an augmented instrument. It is an acoustic grand piano, which has been extended with electromagnets placed inside, just above the strings, so that when they're activated, they cause the strings to vibrate. It's played from the piano keyboard with a new kind of scanner placed at the back, which measures the continuous angle of the keys rather than just sort of on-off, like a typical electronic keyboard would be. And then it's a digital instrument, and like all digital instruments, there's a software element of it, which is responsible for a mapping between essentially what the performer does and the sound that comes out of the instrument. Now, I could basically spend the whole talk geeking out about how I built this and blah, 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 but I'll just make this one point. Essentially, the reason that it works is that piano strings are made out of steel. Steel is a ferromagnetic material. That means you can pull on it with a magnet. So if you put an electromagnet on there and you switch it on and off at the right frequency, you can make the string physically move without ever having struck it with the hammer. You don't even need any speakers. And that's the principle for how this instrument works. I'll show you a short video of how this works, and then I invite you to try it for yourself at the reception after the talk. Okay, so there we go. That's the idea. That video was made in 2011. Now, let me step back from the story for a second, and let's dispense with a myth. The myth is that designing digital instruments is easy or trivial somehow. Because anyway, you can download thousands of music apps on your phone right now. So what's the big challenge, and why are we spending all this time torturing pianos when we have much simpler options available? Moreover, if there are so many instruments out there in the world, why do we even need any more instruments? On the flip side, here's the pioneering human-computer interaction researcher Bill Buxton saying that there are 3 levels of design. You've got your standard spec, you've got your military spec, and you have your artist spec. And the third of those is the hardest and the most important. If you can nail it, then everything else is easy. Okay, so what's going on here? Is this trivial or is this impossible? Well, okay, here's me. This is me. I'm playing the viola in the Kensington Symphony Orchestra. We just had a concert last night, in fact. Us string players, what is it that we expect out of these ridiculous contraptions of wood, metal, and horsehair that we spend our lives with. When you think about it, it's actually pretty extraordinary. I mean, the level of spatial and temporal precision, a large number of degrees of freedom spread out over across a large area. The whole thing is really nonlinear, which makes mathematical modeling challenging. It's a multimodal system, which has not only audio, but tactile cues. And all of this needs to be done basically perfectly reliably if anyone's going to take it onto the stage. And if that wasn't enough for you, then we also have to consider a whole landscape of human skills acquired over many years and cultural landscapes which extend across geography and time. It's actually an enormously difficult challenge to make an instrument that is really suitable for somebody to spend their life with. So maybe rather than asking what's so hard about making digital instruments, we can borrow a question from a paper by my friends and collaborators in Belfast: what makes a good musical instrument? In the case of the MRP, what I had concluded was that a good musical instrument comes down to control. It's about the amount and the precision of control that the instrument provides to the performer. The more control, the better. And what I had done with the MRP is that I had solved an age-old problem with the acoustic piano, which is that you couldn't shape the notes like I do on the viola. Obviously, it needs to be improved. And we can debate that after the talk. The disciplinary basis for how what I would go about this then would be primarily the tools of electronic engineering. We're talking about sensors, about embedded computing, about digital signal processing. And these are the kind of ingredients that will be able to give a richer amount of control. Okay, now let's get back to the story. Enter the accomplice. This is Professor Youngmoo Kim at Drexel University. And round about the end of my PhD at UPenn, Youngmoo saw the MRP and he said, let's see if we can find some funding for this. And so he helped me apply to and subsequently receive a Computing Innovation Fellowship, which was funded by the US National Science Foundation. And with that support, I changed universities and I changed departments, going from a music department to electrical and computer engineering, as a result of which I moved about 4 blocks down the road. Youngmoo was my mentor on this fellowship over 2 years, from 2009 to 11. And he taught me quite a lot about research at the intersection of music and technology. A lot of the ongoing work of the MRP took place there at Drexel. And I also started another project, which I called TouchKeys. TouchKeys is a capacitive touch sensor technology which provides very precise measurements of the location of the fingers on the surface of the keys. And with these measurements, you could use it to provide new forms of control over musical sound. I'll give you some examples. Right, so you get the basic idea. A lot of low-level electronic engineering went into this, and also quite a bit of human factors research in terms of things like playability and ergonomics. But that's not what I want to talk about here. What I want to talk about here is the problem of how you take a new instrument and get it into the hands of musicians when you're in a research environment like this. And this was 2013. I turned to crowdfunding on Kickstarter, which at the time was relatively new for this kind of thing. And I ended up selling a few hundred instruments to musicians around the world, launched a spin-out company, which I led for many years until a different spin-out project, which I'll talk about later, took over most of my time. What I found was that crowdfunding solved a few problems simultaneously. It was good for research dissemination. It was good for commercialization, of course. But then it's also an important way of building a community, which is really important for a repertoire to emerge around an instrument and give it its longevity. Now, over the years, some creative musicians have done some really interesting stuff with TouchKeys. But the funny thing for me has been, I've never really gotten into playing it myself. There's all these degrees of freedom, so many flexible mappings, this can map to this, and it just wasn't clicking for me. Paula and Zubin have figured this out. They're doing amazing things with it. For me, I haven't quite gotten it. I'm missing something. What is it? Well, right about this time, right around this time, yeah. Around this time, a couple things had happened. The first is that I changed continents. I took up an academic position in the Center for Digital Music at Queen Mary University of London, led at the time by Professors Mark Seindler and Mark Plumley. So thank you very much, Mark, for this fabulous opportunity, which has really changed the course of my career and life. The other thing that happened around the same time was that the magnetic resonator piano was still around and kicking. And I was working with more composers and performers at the time. And at that point, a repertoire had started to emerge around the instrument. And what I was finding is that the way that other musicians approached the instrument was often very different from how I did. Almost to the point that they would discover things that the instrument could do, which I didn't even know were there, despite having spent all this time designing it. So on that experience, I actually had to step back a little bit from this problem-solving view of what instruments do to recognize the central role of discovery and creative misuse in making instruments what they are. The disciplinary basis for this kind of area was more in the realm of human-computer interaction. Now, the idea that musicians creatively misuse instruments is actually going to be familiar to all of us, whether we recognize it or not, because there are examples throughout music history of this kind of thing. Adolphe Sax made the saxophone in the 1840s and would have had no inkling of the kinds of techniques that make it iconic across many eras of jazz. And then, of course, famously, the turntable was not a performance interface at all until some pioneering musicians turned it into one in the early days of hip-hop. In HCI, we have a name for this kind of idiosyncratic repurposing. We call it appropriation. And it's basically a long-standing question around how do we incorporate these unexpected directions into the design process itself. One thing does seem to be the case, though, and that's that many digital technologies seem to be more locked down in their interpretation than earlier mechanical acoustic ones. What do we do about this? Well, in 2013, with support from an EPSRC grant, I worked with Victor Zappi, who was a postdoc at the time, to build a digital instrument designed to be appropriated, modified, and hacked. The result we called the D-Box. It's a little wooden cube with a speaker, some sensors, and an embedded computer. And the distinctive element was that you could crack open the side of the things, and you could scramble the wiring of the circuits inside, and it would produce some glitchy and unexpected sounds. We ran some studies with experimental musicians who do what experimental musicians do, and lots of crazy stuff happened. You can look at a video there at the QR code if you're curious. Something else surprising took place in this project, though, because with the MRP and touch keys, I had started with engineering questions and kind of ended up with human factors research. Here I went the other way around, because actually the most enduring bit of the D-Box project turned out to be this little bit of tech tucked in right here. This is an embedded computer which has since come to be known as Bella. To make the D-Box work, I needed to solve certain kinds of challenges around interfacing analog and digital elements, and it turned out that those challenges were shared by quite a lot of different projects in my own lab and elsewhere. But to explain what that's about, let me go back to the interlude about wooden strings with metal and horsehair. Sorry, wooden boxes with wooden strings wouldn't work very well, would it now? So these instruments that we keep on playing after all of these years, we have made a lot of progress in the digital domain in one particular area, and that is the mathematical modeling of acoustic musical systems. Super interesting work happening right now. The idea is that you can essentially take this violin, you can represent the way it vibrates mathematically, you can feed it physical parameters about things like how fast the bow is moving with how much force, and out will come an audio signal, which sounds very convincingly like the acoustic facsimile. You can even run this on high-performance computing so that you can do this in real time. And there's still a big old problem, which is right here. How do we capture the richness of interaction between the human performer and the technical system? Not easy at all. So oftentimes we take the easy way out and do things like this. So it's like we build this, this amazing, beautiful world, and we trap it inside of a sealed glass bottle, and you can just peep in through a tiny little hole. And we can do better. So there remains much to do in mathematical modeling of instruments, but I would say that one of the principal challenges in digital instrument design today is actually the integration of the physical and digital elements. And that's where Bella comes in. It's based on the BeagleBone family of single-board computers, so it's combining the sort of flexibility of a Linux computer with the connectivity to low-level hardware that you would get from a microcontroller. And one of the challenges that Bella addresses is the need for extremely low latency or delay between action and reaction, and also for very precise timing accuracy. It also has quite a high bandwidth of input and output, which is good for providing richer interactions than you might otherwise get with other tools. Finally, the whole platform is open source hardware and software, and our team has spent quite a lot of time building community resources around it. Now, it's worth emphasizing, Bella didn't just sort of spring fully formed out of the D-Box. This was a whole lab effort over a period of maybe 2 to 3 years, using the technology for different research and also for teaching. And it was around 2016 we decided, all right, this is ready to go out into the world. So back to my favorite website, Kickstarter. We launched a Kickstarter campaign, and this one really kind of rocketed away. We just wanted to raise £5,000, and we tripled that in 24 hours and ended up with quite a substantial community of interested Bella users. As a result of which, we launched another spin-out company. This one's called Augmented Instruments Limited, and basically it's growing rapidly, basically entirely sort of under its own power without relying on venture capital. We work with a lot of different companies. We do consultancy work, and the Bella platform is available there also for makers, for educators, and we're building a big community while staying true to the open source hardware and software ethos that the company was founded on. The company was an impact case study in the last REF exercise and is also the sponsor of my Royal Academy of Engineering Research Chair, which is jumping a little bit ahead in time in the story, because this is a project that's still ongoing. But this is around essentially building the technical foundations for new instruments. So, what makes a good instrument now? Well, maybe it's actually about the richness of interaction, which has different facets to it. We could talk about the technical elements, input-output bandwidth, how much information can get in and out of the digital system. But that's closely coupled with a human question, which is the way that the instrument extends the mind and body. Because again, as a viola player, I don't need to spend all my time thinking about what my hands are doing or this object that's in my hands. It can kind of disappear because the technique becomes automatic. I can think about the music I want to play. I can think about the musicians around me. And this is a really common situation with performance in traditional contexts. So we have dueling disciplinary bases for this research now. Electronic and engineering still, but also the cognitive sciences, which really come into these questions of embodiment. In 2016, I set out to investigate some of these links more with support from an EPSRC fellowship that I called Design for Virtuosity. And the starting premise was sort of simple to say but hard to implement, which was basically it takes a long time to learn an instrument, so can we make a new instrument that reuses the old skills that somebody already has without making them spend years of their life relearning? Very, very challenging, it turns out. Now, this fellowship also coincided with a real blossoming out of research directions in my lab. So we did a number of different perceptual studies. We were looking, for example, at how much latency is acceptable in a musical instrument. The answer turns out to be about 10 milliseconds. We did some kind of studies bothering poor unsuspecting violinists with things like tiny violins and violins with the strings put on backwards, just to figure out how much could you stretch somebody's technique before it breaks. And we also started to look into some of the mental processes that underpin musical performance, or at least are purported to do so. This idea of what we might call auditory motor imagery, the imagination of sound in your head, or the imagination of movement. And alongside that, then, there was a lot more creation of sensor and actuator technologies. For example, new string sensors for the violin coupled with a violin body with actuators inside of it, which meant that you could essentially put some digital processing in between bowing the string and hearing the sound, but still have the sound come out right here under your chin. continued to work on new technologies for the keyboard, and also got into sensor systems and augmentations of the electric guitar. Again, a lot of this information is on the lab website if you want to look into these projects. I wish I could spend more time talking about each individual one. But another thing that happened with the lab's research at this time was a kind of widening of the lens. Beyond this focus of the performer here and the instrument there, this sits in a context. What do we know about this context? Why is it important? So we looked at things, for example, around what makes an instrument acceptable to people. It's not just functional or ergonomic, it's also social. Whether an instrument kind of resembles a familiar form or would be something that somebody would want to be seen with. Started to look at questions around the audience, how they experience digital music performance, and basically looked at how the potential for error and risk is actually an important element in making a performance exciting. And then also looked at instrument size in terms of not only how it affects the audience, but how it actually affects a performer's own sense of self and their very own body. Finally, we turned our focus onto the design process itself. Examining questions like, why is it that all these instruments disappear after just a few years, and what can we do about that? We also looked at this quite vexing issue, I think, of instrument design as an academic endeavor, where there are lots of things that wouldn't make it into a paper because they're not really kind of scientific process as such. But these subtle details and hunches and experiences tend to be really important in making an instrument successful. So how can we put a finer point on that? And then finally, this and the last direction, which has become very important to me recently, is looking at the ideology that's baked into the tools that we use. Every programming language, every sensor, every material tells us things. It encourages us to design in particular ways. And do we want to follow those scripts or don't we? These are important questions for us to ask, and we need to be aware of the influences. I want to make special mention of one ongoing collaboration, which is with the OMI Trust. OMI is a disability arts charity which makes and supports instruments for people with limb differences and other physical impairments. And I've worked with OMI for more than 10 years now on student research projects, and more recently I've become a trustee of the charity as of 2021. I have to say, I tend to be really skeptical of sort of lofty promises that technology is an easy solution to complicated social problems, but here is a place where digital technology can actually make a really appreciable difference if it's approached sensitively. Because virtually every familiar musical instrument already needs two dexterous hands. And that's really exclusionary for people who don't have that, who might want to participate in shared musical forms. One example of a project that I've been involved with OMI is a digital bagpipe chanter. This was created by Duncan Mingus, who was the first PhD student in the lab. And Duncan has programmed the chanter so that the entire Highland piping scale is accessible from the fingers of one hand. And Duncan and OMI have made a number of these chanters which are now being used by children and adults around the world. So from that perspective, what makes a good musical instrument might actually be its inclusivity to different individuals and to different communities. The disciplinary bases here being HCI again, but also places in the humanities, especially in disability studies. The final thing that was happening during these EPSRC fellowship years was somehow, annoyingly, the magnetic resonator piano was still insistently there. It was like, I feel like the band that wants to go on tour and play their new album, but everyone's like, no, play your old hit. That's the one we want to hear. So, I have all these people, these amazing musicians who are coming to me saying, can I use the MRP for this, for that? And there's too many to list, really. Xenia Pestova-Bennett I'll name because she's worked with the MRP over a number of years doing some really interesting stuff and discovering a lot of capabilities of it that, again, I hadn't expected. There was an opera written with the instrument. This is by Maria Kaliampa, a film score by the Hollywood composer John Bryan, and a series of shows by the electronic musician Arca, including some that are coming up in Paris at the beginning of March. So this story is very much ongoing, and there's quite a wide repertoire at this point. And kind of grudgingly and gradually, I realized that I needed to start thinking about replicating this instrument so that my own time and availability didn't become the ball and chain that made it stop working. So, what makes a good instrument? Yeah. It's funny. Very good. Yeah. You're a good audience. Yeah. Fair warning. Okay, so this is the part of the talk where we start to go off the deep end. Maybe we started in the deeper end. We're going to go to the deeper end now. What makes a good instrument? Well, it's lots of things. We've talked about a bunch of things. Precision of control, openness to discovery, richness of interaction, I/O bandwidth, extension of the mind and body, inclusivity, and so on and so forth. On top of all of that, let's not gloss over this word here, music, right? Just like we sort of dispensed with the myth that making instruments is easy or trivial, I want to also dispense with the myth that music is some kind of generic or universal quality that instruments neutrally express. You know, you make an instrument to make music and that's problem solved because now we've solved music. It doesn't work that way. It's really important to think about whose musical ideology is encoded in any instrument. And those kinds of questions are things like, you know, in what context would a designer expect the instrument to be played? What aesthetic ideas is this instrument suggesting to the performer, whether obviously or subtly? Thor Magnusson writes a lot of interesting things around this topic, and he talks about how the piano keyboard tells us that microtonality is of little importance, i.e. that notes are organized 12 to the octave, and how many more would you need anyway, thank you very much. The drum sequencer tells us that 4/4 is the most natural time signature. The digital audio workstation, which of course is ubiquitous in music production now, says, oh, it's totally reasonable to repeat the same short performance over and over and over again in the same track. Tools have ideology. They tell us what music should be. So, I mean, look at all the things that are in the mix, right? We talk about, you know, there's tools that go into designing instruments. They're not neutral. They suggest how they shape the way that we think. We have physical objects that we design, you know, bits of circuitry or bits of you know, vibrating material. And both tools and objects will carry musical ideology. And this ideology will shape the way that these instruments extend our minds and bodies when we play them. And in turn, all of this will actually shape our own personal and social identities. And you add all that together and it starts to kind of expand outward. Whole musical cultures are shaped according to these things. Instruments have certain systems of knowledge baked into them. There are economic considerations, there are political considerations. It goes on and on and on and on and on and on in this kind of widening spiral. In human-computer interaction and in the humanities and social sciences, there's a word for this that has become fashionable of late. It's entanglement. Basically, it suggests the kind of irreducible interconnection of humans, cultural systems, and physical stuff. So here's Christopher Frauenberger writing a paper about entanglement in HCI, talking about how these theories make a radical proposition that humans and things are ontologically inseparable from the start, i.e. the very being of things is bound up in their relationality. So, what makes a good musical instrument? Maybe that's not the right question anymore either. Maybe a better question is, well, what is a musical instrument? Yeah. It's, you know, first of all, because in the right hands, in the right musical context, almost anything can become an instrument. And on the flip side, an instrument certainly isn't just an object. You know, we might describe it actually as a kind of constellation of relationships. And you can pick and choose between maybe half a dozen different kinds of theories and philosophies which put a finer point on this basic idea, each of them kind of coming with their own terminology and different kind of underlying commitments. These theories are not here to make a kind of defeatist point that everything is entangled with everything else, so we might as well all just give up and go home because it's all just too enormous to think about. What I take from this is that we get to decide. We get to decide our path through how all these different factors are related to each other. But we have a responsibility to kind of take ownership and accountability of the decisions that we make in navigating these paths. It's kind of, you know, in a sort of situation like a Sudoku puzzle, you know, the minute that you change anything, the constraints propagate outward. Certain possibilities close off, other ones open up. And this means that what might start out as an engineering process ends up affecting a lot more in terms of humans and social political systems. So here the disciplinary bases are quite wide. You know, science and technology studies, music studies, anthropology, critical and feminist theory, and philosophy. this is not the space that I trained in. And I feel a bit like the AI scientist turned critic Philip Agre, who writes in the late 90s about this sort of vertiginous period where he was speaking these strange disciplinary languages in a wobbly fashion at first without knowing what these terms meant. So, forgive the naivete looking back, if you look back on this video either now or some years hence, there's a lot here, and I think it's really important. But on the other hand, just because the problem of musical instrument design is bigger than just an engineering specification doesn't mean that engineering isn't centrally important still. I am still an engineer. I am still an instrument designer. And when I sit down at the bench to build my next instrument, I write some code, I build some circuits. What is it that I'm supposed to do differently because of all of this heavy theory that's now come into the mix? That question is basically what motivates my ERC Consolidator grant. This is a 5-year project funded by UKRI, originally selected by the European Research Council. The point of which is not to try to disentangle instrument design, because that would just be an artificial exercise, but to find productive paths through this entanglement in terms of understanding the cultural implications of engineering activities and to enable more reflective and accountable design practices. It's an important time, I think, to be asking questions like this because, just like 40 years ago, digital technology turned music making upside down. Right now, I think we stand at another precipice where embedded computing with sort of digital systems integrated into everything, and of course AI, is really upending a lot of established practices around music. The question here isn't like, can we do it? Of course we can. People are doing it. It's ubiquitous. The better questions are, well, who is doing this? For what ends and reflecting what values? And those are the kinds of questions that this grant seeks to look into. Now, the ERC grant was ultimately one of the things that catalyzed my move to Imperial and to the Dyson School of Design Engineering. We see the Dyson building just across the street from where we stand today. And design engineering is really the ideal kind of department to be conducting this kind of research because its core mission is around these deep interconnections between multiple domains of engineering and between human and with human factors. And it's really inspiring to be in a department with colleagues who are coming from all sorts of different disciplinary backgrounds. But, if there's a lesson of this talk so far, there is always a wider context. Look, here we are on this campus in South Kensington. What's going on in this campus? Well, there's Imperial College London, but it's not just Imperial. There's the Royal College of Music, there's the Royal College of Art, there's the Royal Albert Hall, there's the Science Museum, there's the Natural History Museum, the V&A, and so on and so forth. This is not an accident either. This area, as many of you will know, is colloquially known as the Albertopolis after Prince Albert, husband of Queen Victoria, who basically sort of envisioned this idea after the Great Exhibition of 1851, where arts and sciences, essentially different disciplinary pursuits, wouldn't be off in their own isolated corners, but would be here proximal to one another and hopefully mutually inform one another. That's a very long time ago now, but it feels like a very current kind of concern. So, just to wrap up in the last minutes of my talk, I want to go back to where we started. And as I explained, I started out with questions around making crescendos on pianos and why we couldn't do this because they're not like violas, they're percussion instruments and you can't shape the notes. Thing is, the story's a total fabrication. It is the story that I told at the time. It took me a lot of years to realize that this story was a fabrication. What it is it's a back rationalization of what I was actually doing at the time. We do this a lot, I think. Yeah. So let's back up further still. At MIT as an undergrad, as Peter mentioned, I was doing a double major in music and in electrical engineering. So I gained a facility with electronics and also with composition and with viola and had a number of wonderful mentors in both departments over that time. But the facets of my life existed a bit on separate planes for a while. They'd come together occasionally, for example, in my master's project at the MIT Media Lab, but I kind of felt like I hadn't found my voice as a music technologist at that point. A few years later, when I was doing my PhD at Penn, I had almost no pieces that I had written for solo piano. Well, so what? Well, I'm a viola player. I'm not a piano player. I can't really play that thing out there very well, to be honest. And I found writing for piano to be really terrifying because, there's centuries of music for piano. What are you going to say for solo piano after all these incredible composers? So the motivation wasn't so kind of top-down and solutionist. It was really more like, well, what if I just kind of change what the piano is about, just a little bit? Maybe I personally will get my own kind of creative inlet into composing for it. And so what I was doing in 2008, 2009 was writing a piece and building an instrument at the same time in a kind of mutually informing way. It was sort of like, what can this technology do? What happens if I try this? Or maybe I have a sound in mind. What could I build that would produce that sound? So it was kind of messy and piecemeal and really in the moment. And I think one of the things that science and technology studies teaches us is that actually a lot of science happens the same way as well. That you might write the arc of it afterwards, but there's the kind of messy in situ explorations I think are really important to a lot of the discoveries and breakthroughs that have been made over many, many years. So in closing, I want to say a few things. The first is that music is important. Maybe that doesn't need saying, but music is a fundamental part of being human. Basically, every society makes music. What's more, every society seems to use the technology of its time to make instruments as well. And the arts can be a really powerful motivator for technological development. As we've seen, basically, there's this huge web of disciplinary perspectives that can inform engineering processes around designing instruments. And I think herein lies some more general lessons for a lot of big societal challenges where engineering can be at the center of what needs to be done, but it needs a real multiplicity of perspectives to be able to address some of these topics. So finally, I'd like to say thank you once again to the members of the Augmented Instruments Lab, to the mentors and colleagues who have supported me and believed in me, especially when my track record was relatively short or slightly strange. And of course, particular mention here of Mark Sandler and Peter Chung, also the current department head Bob Shorten, who are running some incredible organizations and that I've been really privileged to be a part of. And of course, thank you to my family, to my parents, to my sister Laura, and to my partner and now Imperial colleague, Professor Ruth Meisner, in the Department of Computing, and to our little guy who's been an enthusiastic audience member throughout this talk and has taught me a great many things in his nearly 4 years, including how basically anything can become a musical instrument. So, thank you very much for your attention.
Now, we have a few minutes for possible question in the audience, and also we are connected online to possibly some remote questions. So there are very limited opportunity. If you want to ask Andrew anything, here's your chance.
Thank you. I just wonder what you see AI, because you haven't really explored, might affect your instrument. Could it be kind of like remotely people using AI or gesture to control your instrument? Thank you. And what might you teach your kid to play?
What might I teach him to play? I hope he'll be a string player first and foremost, but that's the right answer. AI and instruments, a really interesting topic, and a lot of interesting work being done in there. There's a lot of work being done in the Center for Digital Music at Queen Mary on that kind of topic. They have a whole program in AI and music. Some of the students in the lab are working on that kind of intersection. Some of the things we've looked at are maybe ways that I don't know, that the kind of the relationships between actions and sounds can maybe be somehow more sophisticated or more tailored as a result of AI. Different ways of transforming both sort of sound and gesture. It's a complicated problem, though, because AI also comes with a whole bunch of kind of tentacles that go outward. And like, where does the data come from? What assumptions does that data make? Whose data is that? And it becomes even more complicated when the goal of AI is not necessarily to replace the wooden box with strings, but to actually replace the performer themselves. And there's questions about, kind of whose labor is valued in what way, and what does that mean? So. It's a short question that I think I could spend a half an hour answering, but maybe we should talk about it afterwards. Good question.
Somebody over, yes, that lady in green. The lady in green over here.
Hi.
Oh.
Thank you, Anders.
I think it's your hair. Sorry.
It's okay. It's okay. We're getting there. Thank you, Andrew. You said a lot about what making technology to make music means, and a little bit about why it matters. And my question was more about why it matters. So in a time of acceleration, friction, and carelessness, why does making technology to make music matter?
Oof. Maybe that's a tough question. Well, I think first of all, I go back to music matters, right? The arts matter. It is part of why we are human, is that that we express ourselves in these ways, and that making technology can be an artistic endeavor as well as a purely technological one. And you're right. It's a big question. Why spend a career on this rather than solving the climate crisis, right? I mean, this is a thing that I grapple with over many years. And I guess what I come back to is that there are just sort of certain fundamental things that make life kind of worth living and essentially can serve as a way for us to gather as communities and to share certain important aspects of existence. And we don't want those to become static or to become museum pieces and just say that's that solved and now we're not going to work on it anymore. It might also be that some of the most important things that come out are the ones that I'm never going to be able to set my sights on to begin with. It's going to be that chance encounter where you're building something for this reason, and then that turns out to be used for something over there, and then that ends up having a fairly important effect. So, yeah, tricky question, but I would firmly defend the importance of making music and making technology to do it.
Okay, there is a question online, I think.
Yes, so we have one here from Andrew Cordani. Wants to know, is there potential for individualized instruments rather than individuals learning instruments?
Yeah, absolutely. So this was a idea that I sort of made some steps toward exploring, and I think other people have maybe done more than me in this respect. Can the instrument learn you rather than you learning the instrument? There's a lot that can be done there, and I think maybe some of the idea of designing new technologies that connect to existing skills is kind of in that space. What does somebody know how to do? What do they know how to play? How do we adapt that to the skills that they have? I think that, well, people already personalize their instruments, whether it's spending lots of time adjusting their guitar or even just putting stickers on your case, right? I mean, people personalize the things that they do. I think one thing to be careful about, though, with the individualized instruments thing is to not kind of fall into the trap of thinking that makes the instrument a kind of blank canvas that's going to conform to your ideas, because people adapt so readily and so quickly to the things that are in front of them that there's almost not even a chance for the instrument to sort of learn you as a sort of neutral idea before the ideology that's inscribed in that instrument starts to shape your musical thinking. So, yeah, really a productive area to explore, but also a tricky one.
Yes. Oh, in the front? Yeah.
Well, thank you so much for your presentation. I have a question actually about your MRP. And, Thank you so much for your presentation. I have a question about your MRP. I saw you setting it up with your colleague outside. And, I thought it was interesting how really throughout your presentation, it was polka dotted in there. Maybe you started as something that was really exciting, and then at times were something like, it's coming back again. You can even hear it outside, people playing it. And, I think what I want to know, because it served as so much, perhaps an artistic inspiration, but also some engineering kind of just explosion. What has been maybe the most important thing that experience and building it and sort of living with it has taught you?
You people ask hard questions. I think in some ways the most important lesson that I learned early on, but kind of keep relearning, is that it's not about me, and it's not about what I think it's supposed to be about. That almost all the interesting things that have happened in the last more than 10 years with the MRP have been through encounters with other musicians. But they're not just little individual isolated collaborations that then exist outside of, kind of independent of one another. These people who have used the MRP over the years, in many ways they are the kind of co-creators of the instrument, because their ideas have sort of infused what it is, and then that sort of builds a repertoire and a certain identity for it. And I guess it's been seeing almost like a little laboratory in real time about how kind of new musical practices sort of bubble off and go off on their own from old musical practices. So this idea of kind of one foot in the tradition and one foot somewhere new, and how do you get from being here to eventually being here? I couldn't have planned it, but it's really interesting to watch how it happens.
Rafa, over there.
Thank you, Andrew, for a fantastic talk. It confirms how amazing our school is in bringing people from such a diverse background and types of ideas, etc. Now, my question is maybe a little bit selfish. I'm completely tone deaf, but I do enjoy music. So the tone deafness maybe is a kind of disability. Can you help me?
Sure. I can fix that with some circuits and code in no time. Yeah. I think it's there are many different musical practices, and there are many different ways into musical practice. So I think the first thing is to sort of detach from the idea that if you don't play grade 8 viola, then that's not considered an acceptable musical practice. So if you enjoy music, in a sense, there's no problem to solve. If you want to perform and you find that this kind of stuff is getting in the way, well, then there's probably many ways into that, and it would all be very kind of personal and specific. Probably not best hashed out in this venue right here, but let's talk. Yeah.
One last question on the other side.
Is this?
Fantastic talk. Thank you for all the work over the years. You mentioned that a big part of what you were doing was that serendipity, right? Of sort of getting the work into the hands of some artists or some communities, especially with crowdfunding, etc. And how that really created end results, works, artistic works that you never would have imagined could have happened. You did this from the point of view of being at academic institutions most of the time, right?
Yeah.
And a lot of your focus being sort of also publishing papers, right? And alongside creating the tech, creating the experience, publishing papers with a lot of math in them and a lot of things that can be understood by other scientists, other engineers. How was that ever a blocker? Did that ever get in the way of just getting stuff out there, even crappy stuff that could be artistic, that could be artful? Did it ever get in the way?
Yeah, great question. I wouldn't say that it's gotten in the way, but it does create sort of trouble on all sides. So I mean, what goes in the paper versus kind of what goes out there in the world in the instrument? I actually feel like a lot of the story of my career, and actually the story of this talk, is kind of shifting sort of justifications for why this kind of work is interesting, because I think it is interesting for a variety of different reasons. Some of it's purely technical, some of it's more kind of cognitive science based, or HCI, or humanities, or what have you. I think being in a research environment is a very good place to do this kind of work, because you're certainly spared certain kind of straight down the middle commercial pressures that kind of, you say, well, do the same thing as last year, but make it a different color so that we can, that we can sell it again. And I mean, now that's not to actually to trivialize some of the amazing instrument design work that happens in industry and by individual artists. But the other thing that's, I think, come out of this work more recently is actually trying to think a little bit about what do modes of research dissemination even look like. Maybe research dissemination is and ought to be broader than just what is in the paper. And I mean, that's not my idea. That's not a new idea. That's not even a music idea. I mean, you see this in terms of open science, certain things with data sets, and certain other ways that knowledge about what we've learned is shared. So I think actually it's kind of an opening up of a fairly exciting area. It is academics, and maybe academics is also more than just that PDF file that goes onto Google Scholar.
Okay. Right. I think we're running out of time. So before we close the matter, may I invite Professor Mark Sandler from Queen Mary University of London to give a vote of thanks.
Hi, good evening. It's really hard to know where to start with just such a fantastic talk from Andrew, which explained his fascinating journey through his career and took us all along with him. And one of the things I took away from that is how much you enjoyed sharing that journey with us, and the way you've responded to the questions has been brilliant. So, according to the instructions I've been given, one of the things I do is reflect a little on what you spoke about, and there's not too many things I can feel competent to reflect on in terms of the engineering, the technology, and the musicality. But what I did take away a couple of things, though. Firstly, you have a natural penchant for communicating, and I'm sure we all agree with that. I think, Peter, you said there are 4 qualities. I don't remember all of them, and I think the one you said that Andrew doesn't have is social responsibility. No. This isn't a debate. This isn't a debate. But I just want to shine a light on the deep social responsibility that comes through his work, particularly with OMI. But also, I'll just jump forward into something I was going to say later. We did some work at Queen Mary with an organisation called Teen Tech, which for the older people among you was run by a woman called Maggie Philbin, who was on Tomorrow's World. Hands up who remembers Tomorrow's World? That's a lot of people. She ran this organisation which exposed, I think, 12 to 14-year-old kids, roughly. And Andrew with Ho, who's a technician, he's much more than a technician, at Queen Mary, they put together these brilliant Arduino Tour instruments, which are the shape of a guitar with one string, really, and some electronics. And the idea was to expose young people to technology and music. And they did it for 2-3 years, many, many times. And it was always a crowd puller. So the social responsibility is absolutely embedded in what Andrew does. But for me, it's a message I try to get to students, and I heard it very loud and clear from Andrew. These are your words: openness to discovery and creative misuse. For me, that's a paraphrase for saying, try not to think of your research, those of you who are doing it, as a way of answering predefined research questions, because you won't go anywhere interesting. It's a voyage of discovery, and I think that's what Andrew has just so brilliantly illuminated for us. So, the change of gear. So a couple of things about how he came to Queen Mary. I was head of school at the time. I had stopped looking after the Centre of Digital Music, and we had the opportunity to recruit, and I did what I still do, is I spoke or communicated with an ex-colleague called Juan Pablo Bello, who's at NYU, and I said, who should we approach? Do you know anyone? And he said, you've got to look at this guy. And I did, and there weren't many papers, to be honest. He hadn't published a lot then, but there's another story around. I don't believe too much in necessarily papers at an early career, but you could tell from the quality of his educational background that Andrew was a star in the making, and my goodness, he certainly is. I've got to say this now because I might not squeeze it in later. He's a Renaissance man. Surely he is. So, what else have we got? Okay, one or two little epithets to share. As head of school, it doesn't seem to happen much anymore at Queen Mary, sadly, but we would give a package to new starters, new academics, of probably a PhD student and a computer. But Andrew said, "Can I have an oscilloscope?" And I thought, wow, of course, you've got to have an oscilloscope. Nobody else ever asked that, because who needs an oscilloscope when you've got a laptop? Well, clearly, if you've got an oscilloscope, here's a man who knows how to use it and to put it to great effect. And then a year later, he just reminded me about this earlier. Remember, in a school of electronic engineering and computer science, he won the money for a grand piano as another piece of equipment. So that's who he is. An oscilloscope and a grand piano expresses many things about Andrew. And towards the end of his time with us, this, I hope, isn't responsible for his leaving, but we shared an office. And I'm still there, but he moved on. So, finally, a couple of personal words of thanks for you. You brought a whole new dimension to the Centre for Digital Music, and one that we are struggling to make something similar happen, and that was fantastic. And also, alongside that, we had this PhD program called Media and Arts Technology, and really you brought the melding of those two aspects to it and helped to make it a huge success at Queen Mary. So you personally brought many things to our school at Queen Mary that I value very highly. So lastly, let's all say thanks once again to Andrew, and we can have a drink.
This ends the proceeding for this evening. Not quite. There's a reception out there. Please do stay for a drink and something to eat, I think. There's something to eat. And those of you who are invited for staying on dinner afterwards, stay behind after the reception. I don't know who you are, but you know who you are. So thank you very much for coming, and thank you for logging on remotely.
Thank you, everyone.
Good evening.